Hello again, geometry. So before this video, you should have watched how to simplify square roots. We are now going to review some other square root properties in preparation for working with special right triangles, which you guys will see next video. So I can multiply and divide square roots with a couple simple rules here. Okay, we're not going to look at adding and subtracting. That is something that you will see down the line. However, you do not need to know that skill for our special right triangles coming up. So when I multiply two numbers with a square root term, okay, we can think of this almost as just like multiplying variables, right? So if I have some 2 times some variable times 5 times some variable, I can multiply my coefficients, the 2 and the 5, to make a 10. And I can multiply those variables, right? In this case, they're not variables. These are radical expressions, our square roots. Anything, the way I like to say this is anybody outside the house can play with others outside the house. So that 2 and 5, let me highlight actually. So the 2 and 5 can, say, play with each other. So 2 times 5. And anybody inside the house can play with whoever's inside the house. So the 3 and the 2. And they stay inside the house. So I have 10, 2 times 5 is 10, times the square root. So I'm not actually writing that multiplication symbol there. And just like a coefficient on a variable, multiplication is implied. Same thing here. So 10 times the square root of 3 times 2, or 6. Okay, and then the way I know that I am in simplest form is I'm going to ask myself, are there any perfect square numbers that are factors of 6? Well, let's think 6 breaks down into 1 and 6, 2 and 3. None of those numbers are perfect squares. 1 is, but that's the form I'm in. So that is my final answer. Okay, you always want to simplify if you can. So that's multiplication. It's very straightforward. Here are 2 division problems. So the same thing holds for division. Okay, so this 2, I'm going to divide. There's an imaginary 1 out there, just like on any variable without a coefficient. And then the 6 and the 3 under the square root can also be divided. So 2 divided by 1 is just 2. And the square root of 6 divided by the square root of 3, again, I'm going to keep everything under the square root. This is going to be 2. And there's my final answer there. Very straightforward. So this last problem, right, doesn't look like there's very much to do with it. One of our mathematical acceptances is that we never leave our answer, or our answer is never in simplest form if we have a square root or a radical in the denominator. Just like in exponents, right? We never leave, it's not simplest form if we have a negative exponent. For example, say x to the negative second. You never leave your answer like that. We would rewrite that as 1 over x to the second. Okay, so this is another, we call a mathematical rule. We never want to have the square root in the denominator. I need to get rid of that. So we're going to do something called rationalizing the denominator. And all that stands for is, in plain terms, we are getting rid of the square root in the denominator. And the way that I'm going to do this is I am actually going to multiply, change this into a multiplication symbol, this fraction by the square root of 2 over the square root of 2. Okay, so why would I use the square root of 2 over the square root of 2? Well, if you think about it, anything divided by itself is just the number 1. So this right here, this fraction that I wrote here, just represents the number 1. Okay, so I am just multiplying this by the number 1, which means I'm going to end up getting itself again, right? I am just creating an equivalent form of this fraction. It's just going to look a little bit different because it's not going to have a radical or a square root in the denominator anymore. So this is just like when we create a common denominator. So off here on the side. So say I use, right, we had a simple problem, 1/5 plus 2/10, right? In order to carry out this problem, I need to create a common denominator. And I would identify that as being 10, right? 5 is a factor of 10. So to do that, I would multiply this fraction by 2 over 2. In other terms, I'm just multiplying this by 1. So I'm doing the exact same thing here, right? And I end up with 2/10, which is still 1/5. It's just an equivalent form of that. So I'm doing the exact same thing here, and watch what happens. So when I multiply straight across, right, fraction multiplication, multiply numerators and denominators, I end up with 4 times the square root of 2 in the numerator, divided by, so remember, numbers inside the square root, multiply with numbers inside the square root, keep them in there. The square root of 2 times 2, or 4. And hopefully, you guys are noticing that square root of 4, well, we can do that. That's just 2. So I end up with the square root of, or 4 times the square root of 2 over 2. And we can actually do one more thing with this. If you notice, back to our radical division, we can divide our coefficients here. So I can simplify this one step further and do 4 divided by 2. Let me just circle that so you guys can see that nicely. 4 divided by 2, and actually simplify this to 2 times the square root of 2. So rationalizing a denominator is something that you are going to see in our special right triangles unit coming up next.